Welcome back. We're going to look at lesson 13.2 in this video. 13.2 deals with correlating number of stars in Yelp reviews with linguistic features in the text of the review itself. Okay, so that's what we're going to do. That's the objective, that students will correlate the number of stars in Yelp reviews with linguistic features of their choice in the text of their actual review. Okay, so the logic here is that you create a CSV file with as many rows as there are reviews. So you have a CSV file which has a tabular data set, right? Rows and columns. And you have as many rows as there are reviews in the JSON file. So in the case with our sample JSON file from 2018 Arizona reviews, there were almost 120,000 reviews. So we should create a CSV file that has almost 120,000 rows. And we're going to create several columns here. Business ID, perhaps, number of stars, and then importantly here, the number of occurrences of the linguistic feature in each review, which could be 0. In fact, the majority will probably be 0, meaning the current review does not have the linguistic feature I'm looking for, but the next one does, and the next one down has like 2 occurrences, and then the fourth one down has none, 0, right? So that's the logic. And then what you do after you create a CSV file is that you import that CSV file either right back into Python, or you can use some other software like R or Julia or Excel, and you get the Pearson R correlation value between the columns. Well, the column with the number of stars and the column with the number of occurrences of linguistic feature that you're looking at currently. And that gives you a Pearson R correlation. That Pearson R correlation ranges between -1 and 1, if I'm not mistaken. If it's positive, between 0 and 1, there's a positive correlation. If it's negative, then between 0 and -1, then it's a negative correlation. And then you get a p-value as well. And then it's good to also visualize those same 2 columns with the scatter plot with the regression line, which is a straight line that shows the overall trend through the data points. You want a regression, you want a scatter plot regression line. Okay, so let's give this a try. Using the JSON file with the Arizona 2018 Yelp reviews and the CMS that we used in the previous lesson, you're going to create a CSV file with 2 columns, just 2 columns this time. Column A will be the number of stars in the current review between 1 and 5, right? That's the number, that's what Yelp reviews have, between 1 and 5 stars. And then column B will be the number of occurrences of the word delicious in the current review. Again, it could be 0 or 1 or 2 or 3 or more, right? So that's the first thing here that you need to do. So give that a try. See if you can create a CSV file that that does that. That creates 2 columns with almost 120,000 rows, 1 per review in that JSON file. Looking at the number of occurrences of delicious. You're going to need re.search probably, right, to find a regex. Make sure you get your word boundaries around delicious, right? \B is the word boundary in regex language around delicious. Make sure you don't worry about capitalization. Use the flag equals re.I to not worry about capitalization in your re.search function. Okay. Stop the video and give that a try for a few minutes. All right, welcome back. Let's take a look at how I would accomplish this one. All right, so we import JSON and RE. On line 2, we open up 2 connections here. The first connection is to the JSON file on my hard drive that has the 120,000 reviews, right? You know, I don't think I even need to specify the encoding because I believe the default would be UTF-8. Okay, so I'm going to open up a connection to that. The mode here is read, which is the default, so I don't need to write it, but I will just to be very explicit here. I'm reading in. I'm going to say that connection as fin for file in, comma, and then I'm going to open up an out connection, a connection to an out file. To on my downloads, I'm going to create a review dot underscore data CSV. I'm going to write out, so I have to put W there. Save that as a variable name. I'll use f out for file out. Right, so you can open up 2 file connections with the same with keyword if you have a comma between the 2 connections there. And then I'm going to write out a header to the out file of stars, comma, and features new line break there. That'll be the first row when I import it into this spreadsheet software. Then I'm going to loop over the in file, each line. I'm going to convert each line, which is a string, into a dictionary on line 5 there. And then I'm going to search for this regex. Right, I have my old friend R right before the opening quote. Then I have \b, which means word boundary, and then the word delicious, then word boundary, \b. And then I'm looking in the review text. So I have to index into the dictionary, the current reviews dictionary, and say I want to look at the text. This is where I want you to find delicious. And then I also have the flags equals re.I to not worry about capitalization, right? So it will find lowercase delicious or uppercase delicious or combination, like, capital D and lowercase, the rest of the word. Okay. And then once you've done that with re find all, I actually use find all here because it returns a list of matches. And then I just want to know how many matches there are. If there are none, it'll return 0. The length is 0. If there's more than 0, it'll return the exact number that there are. So on line 7, I'll save it to a variable called num matches. And then with the out file connection, I'm going to write it out. I'm going to convert into a string the number of stars, which is a number. And then I'll concatenate that with a comma, because that will be the separator between the columns in the CSV file. I use a comma up here, right here on line 3 with the header. So I need to use a comma here. And then I will push to a string the number of matches of that regex, and then a new line break. Okay. So let's see this run. Let me just run the script. And it may take a few seconds here. I don't have a progress report, but I could. There you go. Exit code 0. Good. So I should have in my downloads, let me just go verify. In my downloads, I should have review data.csv. Let me go to my downloads. And there it is, review data, CSV. Let me just open it up and see, just look at it in a spreadsheet software, just to look at it before we go to the next practice exercise. So it's 716 kilobytes, so it's not massive. I need to use commas here, not tabs. And I'll say okay to import it into spreadsheet software. So review 1 had 0 occurrences of delicious, the first 11 reviews. But then here, the 12th review on line 13 gave 5 stars and had 1 occurrence of delicious there. You can see the majority of these things don't have the word delicious in them. But unsurprisingly, the ones that do have high ratings. Quite high ratings here, right? Well, we got 2 occurrences of delicious in here. Okay, so yeah, it worked. And let me just jump down to the bottom of the range, the data range. Yeah, 119,377 is the last row there. We have 1 fewer reviews because we have a header row, right? Okay, so that worked to create a CSV file going through these reviews. If you'd like to pause the video and take a look at this code or look at the code in the solution file, you can do so now. All right, let's ramp it up. Let's see what else we can do here. Use the CSV file created in the previous exercise to calculate the correlation between the number of stars and the number of occurrences of delicious. For this practice exercise, you can assume a normal distribution of the data and therefore use the most common correlation tests Pearson's R. There actually are assumptions. There's parametric correlation tests like Pearson R is, and there are non-parametric ones like Kendall's tau and Spearman's rho. We're just gonna, for the moment, assume that we can use the Pearson R correlation tests. And if you want to look at this right here, this Stack Overflow thread, and they say, I'm looking for a function that takes as input 2 lists and returns the Pearson correlation and the significance of that correlation. And here is a response. You can see here that you're going to need to download SciPy. SciPy is a module. You'll need to pip install it or go into the preferences window in PyCharm and install it. We've done that quite a few times now. And then if you do from scipy.stats.stats import Pearson R, then you can just pass in, we're gonna have to install pandas as well. Pandas is a module that allows you to work with data frames like CSV files that come in as tabular data sets, that is columns and rows. And you pass in the 2 columns. Okay, so give that a try. Give this a try. You have to Google around a bit to figure it out, especially the pandas part. Ready, set, give it a try. All right, let's take a look at how I accomplish this. So after it's created all this, I'll just kind of comment it out for the moment, just so we can just remind ourselves that that code created the CSV file. And then here, so again, you have to install what's called pandas. Pandas is a module that works with tabular data sets, right? Data sets that have columns and rows. So I'm going to read in that CSV file that I created previously, right up here. And the separators is comma, so I'm going to tell read CSV that. Save it to a variable, I'm going to call it Yelp. And then from SciPy stats import this one function Pearson R. And then the way you index into a column in a data frame is you give the variable name that's holding the data frame that I created on line 12. And then the column name is num features and stars, right? That's what we saw back over here. Let me just open it up real quick again. Let me jump to here and just open that up, comma. So you can see that the column names are stars and n feature. So that's what I put here. Those are the column names. Okay, and I throw those into Pearson R, and then I print out that correlation. It prints a 2-item tuple, and the first element, or 2-element tuple, the first element is the correlation coefficient between -1 and 1, or like I say there. The second element is the p-value, which indicates statistical significance. Values at or below 0.05 indicate statistical significance. So let's run this little script. And there it's done. Down here in the console, I'm looking now. So we have the 2-item tuple, the 2-element tuple. The first element is the Pearson R coefficient. And we have a 0.15 and it's positive. So that means there is a positive correlation as number of uses of the word delicious go up, the number of stars goes up. That's what the positive correlation means. And the p-value is given as 0. So apparently very low. I assume there's an actual number here, not 0, meaning I assume it's like, decimal point and then maybe 100 or something, zeros, and then some number. But they just rounded to 0 here. Okay, so that right there is the code. Again, you need to import this pandas so we can use the read_CSV function to create a pandas data frame. And then we need to also download the SciPy module and use this function, within SciPy. Just on line 15, you say from scipy.stats.stats, import this one function called person R. And then we throw into person R 2 columns from the data frame using a column name as after the variable that's holding data frame dot column name. And then we just print it out to the console down here so we can see it. If you'd like to pause the video and look at that, go ahead and do so now. Okay, let's keep rolling. Correlate the number of stars in the reviews in the Yelp data set with the number of times a vowel is repeated 3 or more times. For example, this restaurant is way better than that one with 3 A's in there. Or that business is so overrated. All right, so we're going to create another CSV file with right number of stars in each review and number of occurrences of 3 repeated vowels in the review. Okay, I don't know of any English words that have the same 3 vowels, the same vowel 3 times. So it's, you know, like it's one way of exaggerating, right? In social media, and right, to exaggerate something, you repeat a letter a lot. And vowels are often those repeated letters because we can hold out vowels in our speech much longer than most consonants you can. All right, so give that a try. See if you can do that. You're gonna have to change the regex. The main thing here is you have to change the regex. All righty, let's take a look here. Oh, you know what? Real quick, I didn't show you a scatter plot. I think that was part of the last. Sorry, I think that was part of the last. I guess I didn't ask for a scatter plot, but let me show you a scatter plot real quick of delicious before we move on past this into the next one. Let me show you. So yeah, you have to install some more packages here. Matplotlib and Seaborn are 2 packages you'll need to install to do scatter plots in Python, to do plots in Python. Let me just explain it while it's working here. So import matplotlib, pyplot, and I'll just use an alias of plt. Import Seaborn, then I'm going to use this lm plot, which gives me a regression line. And so I say the x-axis is the number of feature, the y-axis is number of stars, the data is called Yelp, it's in a variable called Yelp. Then fit reg equals true means fit a regression line. Show me a regression line there. And then you have to actually say plt dot show there. So I don't know if you noticed, but down here it opened up another application here on my computer. And on Mac, it looks like a rocket with the Python symbol on it. And it probably is something different on Windows. But you can see that here on the x-axis, we have num features and features. So as the number of occurrences of delicious goes up, the number of stars goes up. And that's why that regression line is positively sloped. All right, so as number of uses of delicious goes up, the number of stars also goes up, which is what we'd expect. Right, so we have that positive regression line. And when you shut it down, it should shut that down. Okay. All right, so sorry, jumping back to the one about repeated vowels. Let's try that. And I'll just jump right into analyzing with the person R as well as the scatter plot. Let me get all of this over to my little chalkboard. So let's jump and look at the actual regex is really what the difference here is, simply changing that regex a bit. So what we're doing here, let me zoom in on that regex. And I'm using find iterator here. The regex is right here. We have R before the opening quote. And we have a parentheses around this stuff. And that stuff is a character class. You can see we have square bracket, right? Square bracket, closing square bracket. And within those square brackets, we have the 5 orthographic vowels, A, E, I, O, U. And what the parentheses does is it captures it. It holds on to it in memory. It says, okay, I see I have a vowel here. And then the \1 says, I want another instance of that thing you just remembered, whether it's A or E or I or O or U. Whatever you just remembered, I want a second one of it. And then actually here with the curly braces, 2 comma curly brace, that means I want 2 or more of the previous thing, which was whatever it remembered. So we have 3 vowels. We have the first vowel here that's remembered, and then we want 2 or more of it right after it. So that is, we want 3 or more of the same vowel. Okay, this gets into capture group with those parentheses in the regex. If you need to review lesson 3.1, pretty sure it's 3.1, you can do so there, but that is the regex that would find a vowel repeated 3 times right next to each other. And we're finding that in the text as before, and we're not worried about capitalization of the vowels, so it could be uppercase vowels. And then let me zoom back out a bit. And then, okay, so we're using find iter here. You probably could use find it all, I bet, as well. But anyway, right here, I have to push it to a list, and so I just do I for I in match. This could be M for match. We want to be a little bit more transparent. M for M in match. So give me all matches. Save it to a list. The square brackets there says turn it into a list. This is list comprehension, and then just give me the length. That's what len does, right? So I want the number of occurrences of a repeated vowel, and then write those out. Write those out to the CSV file. So it should overwrite the previous file. Let me just shut that down. It shouldn't have a problem on Mac overwriting it while it's open, but review data will be overwritten here in a second when I run this. So it's going to run it. So this first part between lines 1 and 10 is just going to run this part where it's going to parse through the JSON file. It's going to write out to the CSV file at the same time as it's parsing through each one. It's going to look for repeated vowels that have 3 or more vowels repeated. And then that will do that. It'll save a CSV file out to the hard drive, review data, CSV with the underscore between review and data. And then I'm going to jump into this next section where I'm going to get the Pearson R correlation. I'm going to import pandas, read in the CSV file that was created previously. And then I'm going to pull in SciPy, the Pearson R function, and then just print it out to the hard drive, or excuse me, print it out to the console. And then I'm going to jump into the plotting where I'm going to plot a regression line in a scatter plot. So do all that at once. Here we go. Ready, set, go. It's working. Okay, so I printed out the correlation right here. The correlation coefficient is at 0.02. If I were to round up, 0.02, it's pretty low, pretty close to 0 rather than 1. It is positive though, right? So there's a positive correlation, and it is significant. This second number is a p-value. And you can see that E minus 0.9, which means you move the decimal point 9 spots to the left. So we move this decimal point between 6 and 7, 9 decimal places to the left. And we end up with a number that is decimal point, 8 zeros, and then 6, 7. So the p-value is way below 0.05. So it is a significant correlation, but the actual correlation coefficient is kind of low. But we can see a positive correlation visually here with the regression line in the scatter plot. All right, so as number of repeated vowels 3 or more times increases, the number of stars in the review increases like that. All right. Like to pause the video. Well, you know what? You should look at the solution file. This is the only real difference from before is this regex, just what we're searching for, the linguistic feature that we're searching for with the regex. And this is a little bit different here. I use find iter, and I had to do list comprehension there to get the number. So that's a little bit different line 7, or excuse me, 8 and 9 are a little bit different from the previous exercise. All right. If you'd like to pause the video, do so now, or look at my solution file. Okay, let's see what we got here. We're just going to do some more exercises of linguistic features. Correlate the number of stars and reviews with the number of times double quotation marks are used. Okay, so double quotation marks. See if there's by chance some, correlation between how people feel about the business or the restaurant and the number of times they use quotes in their review. Perhaps they're using like sarcastic quotes, like "this is so good" with quotes when it's really bad. I don't know. Maybe that's what's happening. So we can take a look by finding the number of double quotes in the review and correlating that with the number of stars. Again, it's simply a matter of changing the regex in your script to find double quotes, number of double quotes. Okay, so give that a shot for a couple minutes. All right, let's see how I went about this. Yeah, again, this is all the same except for the actual regex. So let's jump to the regex, which is right here. And that's it. Right here on line 13. It's just regex. And I'm using single quotes. This is a little bit confusing here because there's a lot of quotes happening here, but this is actually a single quote to start the regex. And then I have a single quote back here to stop the regex. And right in between, I have a double quote. A little bit hard to see. They're kind of jumbled together, but I think you can see that the two middle vertical lines are closer together. That means that's a double quote. And we just have single quotes on either side. All right. So let's just run that. Let me just back out a bit. And everything else is the same. Well, okay, so I am using find all here. And then just calling len find all, or excuse me, len on the find all object there. This is all the same, reading in the JSON and reading and writing out to the CSV. And then when we're done with that, we come in and use pandas to read in the CSV. And we use this /r function to get the correlation. And then we plot it up with this little bit of code down here with the regression line. So let me run that. Oh, okay, so yeah, it's still running the previous plot. It actually causes Python to actually run. Let me close that down. Okay. All right, so we have a negative correlation here. So negatively correlated. So as number of double quotes increases, the number of stars goes down. That's what the negative correlation coefficient means. And it is significant. The p-value is way below 0.05. It's at 0, supposedly. And visually, you can see, yeah, that correlation line is going way down. So when people use quotes in their Yelp reviews, they often are not happy with the restaurant or the business as their number of stars goes down, as the number of quotes goes up. Okay, so that's a negative correlation there. Again, the only thing I changed from the previous exercise was the regex itself right there. Looking for number of double quotes. Okay, if you want to pause the video and make it work on your end, you should do so now. All right, I'm going to go ahead and stop this so it stops the script. And then here, I encourage you to choose another linguistic feature and be prepared to share with someone. Perhaps this is not applicable this semester. But anyway, so you could just simply change the regex and find something else. Let's see, what should I do? I'm talking to myself here, but what should I do? Just for fun, I'm just going to put the word gross in. I assume that we'll have a negative correlation with gross, because as the number of occurrences of the word gross goes up, I assume the number of stars should go down. if we're dealing with the restaurant, right? Just for fun, I'll put in some more words here when it finishes with this. Let's see. Yep, as I suspected, as the number of occurrences of the word gross goes up along the x-axis, the number of stars goes down. That's just a word. I mean, if we wanted to look at other linguistic features, we could do so with a regex if we can, you know, code up the linguistic feature in a regex. I don't know, I'm blanking here on other things I could do at the moment. But anyway, you could just simply put in whatever regex you want and see how it correlates with number of stars of reviews in Arizona in 2018. Okay, so that brings us to the end of this lesson here of 13.2. At this point, you should be able to correlate the number of stars in Yelp reviews with linguistic features in the text of those reviews. Okay, great. Thank you so much. Bye-bye.